Your challenge, though, tomorrow will be with your group to design a lighting system that is going to light up hieroglyphics. What we have in our tombs, we have these vulture hieroglyphs, and they're in the walls, or pasted on the walls in different locations. So this is the north side of the tomb, and there is a hieroglyph way down there on the bottom. This is the south end of the tomb, and there's a hieroglyph right here. And then there's an east side, and there's one right there. And there is a west side, and there's 3 hieroglyphs there. And the other thing is there is a grid, like a graph paper on the bottom that will help us as time goes on. I will show you how to use that. So most of the time when you're using this, you've got the lid on. So right down here, I made little tabs, so these are like doors. This is like a drawbridge. You pull this down, and you're going to put your flashlight right inside there. There's little doors that you can look in to see where your light is shining and how many hieroglyphs it's shining on. So we won't talk a lot about this right now, because I'll go over any questions that you have a little later. But do you have a short comment that you wanted to make right now?
So technically, you're just trying to make it light and dark, like Zane's trying to get the light in there but not fade out.
So our job will be to try to get as many of those hieroglyphs lit up.
So technically we're Zane trying to do something.
Yeah, right. You're going to be optical engineers, and you're trying to figure out how to light up these hieroglyphics, but you only get one light source. But you do get other materials that will help you. So let's stop right there. So you already said light travels in a straight line until it is blocked, absorbed, or reflected. And our second part of our question is, how can we measure its intensity? And that is what we will do today. Over here are some hieroglyphs. I'm going to come up about here. Okay, I'm going to hold this. Can you describe what my light looks like? Lexi.
The intensity is kind of low, and I know how you can make it higher or even lower.
The intensity?
Yeah.
All right, how would I make it lower?
You would make the flashlight go farther away from.
All right, so let's see. How are you able to see them? Is it getting better? Is it getting worse?
As you're backing up, the light's getting dimmer.
And the light's getting dimmer?
Yeah.
The intensity has to do with how bright it is over distance. Okay, so the greater the distance from the light source, the blank intense the light. I'm going to give you a choice of words, more or less. The greater the distance from the light source, the less intense the light is. So let's spend a little bit of time doing this. How can we measure intensity? And what I have for you is intensity measurers. I'm going to pass them out to your groups, and you can look them over for a minute.
How does it measure light?
No, it just shows you the intensity that it has. Like this has, I guess this has a lot. I guess it's on a backwards scale. This is pretty dark, and then that one's really dark.
Wait, it's supposed to go like that. Oh, I'm serious. This is a lot of light. This is kind of.
I think the numbers are backwards.
Yeah.
Okay, folks. If you were to look at the 0, what word would you use to describe that square? Wyatt?
Transparent.
Transparent. Yep. light can transmit right through there. So let me show you your process here. And I'm going to look through and see if I can see the vultures. And I can. But the importantest thing to see about the vultures is the black part of their eye and the white part surrounding their eye. And I will just circle that part around that. And it's really important to be honest, because as scientists, we can't report what we want to see. We have to report what we do see. In your notebook, you have a place to record all this.
I can't see it at 3. Now let me see. Okay. Do that side over there with the 3. Yep, I can see it with 0. Definitely. That's clear. See it at 3. He can see it at 3, but I can't.
Well, you each have your own papers, so you can fill what you see.
See if we can see D and F. I think I can see it. So can I. I can still see it. So can I. I'm 4.
Hieroglyph C. What did you get?
3. I got 3.
Anybody get something different from a 3 for hieroglyph C?
I got a 2.
You got a 2?
Finally. 4.
Ooh, anybody else 4? So C got a 2 and a 4 and a 3. I'm going to give it a 3.
Yes.
You know how I did that? I just averaged the 3 numbers together. Take a look up here with my light intensity meter. So if you look at your boxes 3 and 4, if you can see something through box 3 and you can see something through box 4, you must have a high intensity light. The light is closer to that one. And if you have boxes 0 or 1, then you have a low light intensity. So there's probably a further difference between the light and the hieroglyph. All right, good job. In the unit, they need to understand how light behaves around any kind of material, so that when they are actually doing their challenge, they are able to anticipate what's going to happen depending on what they use as material to increase the intensity of their light beam. As far as using visual aids in my room, I know that there are children that learn in various ways, and to have the information, for them not to have to keep that information all in their head, but to have it on paper where they can access it and keep referring back to it is very, very helpful for them.